Yep. All right, let's give this a whirl here, people. So I'm basically going to work out the all the problems that I've assigned for you. Tried not to assign too many. I've actually broke the assignments up in half from previous years. Not designed to stress you out or anything like that. Just want to get you ready for the AP test as we approach stuff that we haven't done. Obviously, I'll just take a second to explain it on this video. It's not going to be perfect. I'll probably be changing all sorts of the ways I do things as we go, just because I'm experimenting with a lot of different types of software right now. But let's just get right to it. So, Duff, pay attention. Come on, get your head up. Let's go, rock and roll. All right, so let's start with question one here. So this is from the first assignment. So question one. This is a little annoying. I got to do the thickness every time, but we'll figure it out. All right, here we go. Question one. Here we go. Simple integral. We got the integral from 1 to 2 of 4x cubed minus 6x dx. All right, so integral of a difference, as we know, is the difference of integrals. So we're going to rock and roll with this. So now when we go to do it, you have a constant times a function. So the integral of that is simply the constant times the integral of the function. So applying the power rule there, we're going to get 1/4 x to the fourth. Minus, here we go again, constant times a function. So the integral would be 6 times the integral of x, which is 1/2 x squared. All right, there's our antiderivative without the plus c, right? Because we're doing a definite integral evaluated from 1 to 2. And I can spruce a little bit. These 4s, a little action going on right there. 2 goes into 6 3 times. We're all excited about that. I'll go back over here and spruce this up one more time. So we have x to the fourth minus 3x squared. All of this evaluated from 1 to 2. So fundamental theorem of calculus now says first chuck in 2. So 2 to the fourth minus 3 times 2 squared. That's like my f of b. And then we chuck in 1. So that's going to be 1 to the fourth minus 3 times 1 squared. That's like my f of a. And we rock and roll here. So 2 to the fourth, I believe, is 16. 2 squared, 4 times 3 is 12. It's my first little chunk of info. And then here we have minus 1 minus 3. That's negative 2. So we get a little minus action there. So we end up getting 16 minus 12, which is 4, minus, which is plus 2. So we get 6. And we look, and that's choice C. And everyone's excited. So we make a little smiley face. All right. Observe the flow. All right. Let's go rock and roll. Let's go question 2 here. Question 2, we have f of x is equal to x times radical 2x minus 3. And it's asking for f prime of x. All right, so Maddie, what do we got there? No, good try though. All right, so we have a product, Maddie. So product, right? This is our first factor in the product. This is our second. So in order to take the derivative of a product, we have to use the product rule, which in our own words says... What do you think, Duff? Good job, Duff. All right, you got it. So first times the derivative of the second. But when we go to take the derivative of the second here, you have to view that as a composition, right? So it's radical stuff. And so the derivative of radical stuff is going to be 1 over 2 radical stuff, right? Don't mutilate stuff, times the derivative of stuff. That's the chain rule in effect there. The derivative of 2x minus 3 is going to be 2. All right. So then we go plus, that was just first time derivative of the second. Then we go plus second times the derivative of the first, and the derivative of x is just 1. So howdy doody time, we're rocking and rolling. So you can spruce a little bit here, right? These factors of 2 are going to cross out. So you're going to get x over radical 2x minus 3 plus radical 2x minus 3. And you're loving life and you think you did it right and your calculus is spot on, and you go and look at the choices and you don't see any of those. So what do? Well, you can put this over 1, right? View this as 2 fractions and basically just add the fractions. How do you add fractions? Well, we learned in elementary school that you need a common denominator. All right, so you can multiply this by radical 2x minus 3 over radical 2x minus 3. That would be your least common denominator, and then you can go get them. Or you can use a little shortcut, which really isn't a shortcut. It's just what I just said, just algorithmically. That's even a word. So here we go. So you always start in the top left corner. You multiply on this diagonal. That's going to be x. X times 1 is x. Always keep the sign. Say that. Keep the sign. Say it. Good. All right. Then you're going to multiply on the other diagonal. That's the second thing you do. That's what those numbers are. Radical 2x minus 3 times radical 2x minus 3 is going to be radical 2x minus 3 squared, which is just 2x minus 3. So let's write it that way instead. Okay. And then all over, the third thing you do here, what you get when you multiply the two bottoms. So all over radical 2x minus 3 times 1, which is that. Okay, this isn't magic, guys. This is just basically multiplying this fraction by radical 2x minus 3 over radical 2x minus 3. This little method will always work. It's not the most efficient always if you have common factors between the denominators. We didn't, so that's why it looks pretty. All right, it'll always work, though. You just might have to simplify later. All right, so here we go. So you have x plus 2x. That's going to be 3x minus 3, right, when you combine like terms, over 2x minus 3, and now you're praying and you're saying, hey, is that a choice? And it looks like that is choice A, and you're happy. All right, so there you go. Question 2. Ba-blam. All right, let's go to question 3. So question 3, we have the integral. Duff, come on, bud. Get that head up. We have the integral from A to B, thank you, of f of x dx, and it's telling us that that happens to equal a plus 2b. All right, sweet. So now they want you to find the integral from a to b of f of x plus 5 dx. All right, so what's the story there? Don't overthink it, right? This is probably what I would say to you guys. Hey, take 15 seconds and discuss this and walk around, and maybe some of you got it, maybe some of you didn't. Don't overthink it, right? You have the integral of the sum. What's the integral of the sum? It's the sum of integrals. So your first thing that you're writing is you're not getting cluttered with this given. You're basically just saying, all right, well, I know I can write this. This is bread and butter, integral of the sum of the integrals. And then you're like, whoa, check that out. This was given to me. So that's just a plus 2b. So extremely excited about that. And so now you're like, what do I do with that? You do it, right? So integrate 5. Give me a function whose derivative is 5. That would be 5x. Evaluate it from a to b. And you got that a plus 2b. That's just kind of chilling. And then here you got 5b minus 5a. When you do the fundamental theorem of calculus, you combine like terms like you learned in middle school. And maybe I'll do the b's first, right? So you're going to get 7b when you add those, right? 2 bananas plus 5 bananas is 7 bananas. And then you have a and minus 5a. That's negative 4a. And we're looking good. And so now, is that a choice? 7b minus 4a? Yeah, it's choice C. All right, so again, that deserves a smiley face. All right, any questions? I didn't think so. All right, so here we go. So let's go to question 4. We got to scroll up over here so I can see it. Here we go. All right, so question 4, we have f of x, and it's equal to negative x cubed plus x plus 1 over x. And then you're asked to find f prime of negative 1. All right, so same deal, right? They want f prime of negative 1. You're going to be like, well, you know what? I'm going to find f prime of x first. That's what you got to do. So leave a little space here. So f prime of x, right? Integral of sum of the integrals, just easy breezy town here. Right? The integral of this would be negative 3x squared. Integral of x, integral, what am I talking about? I must be drinking too much caffeine. That's the edited version of what maybe I normally say. All right, so here we go. So negative 3x squared plus, sorry, that's the derivative of that, right? And then the derivative of x is just 1. And then the derivative of this, maybe you just have it memorized, negative 1 over x squared. Maybe you don't. If you didn't, right, f of x, notice not a derivative symbol here. I just rewrote it. So negative x cubed, because that's good to go. X is good to go. Maybe I want to write that as x to the negative 1. Because if you don't have that memorized and you don't want to do the quotient rule, which quite honestly would be silly to do on that, although it would work, you could do the power rule. So the power rule would give you negative x to the negative 2, which is basically that. All right. All right, so rocking and rolling, you got f prime of x. You want f prime of negative 1. So negative 3 times negative 1 squared plus 1 minus 1 over negative 1 squared. So that's going to be 1. That's going to be negative 3 plus 1. It's going to be minus 1. Blah, blah, blah. Answer looks like it's going to be negative 3, which is choice D. Again, happy face. Clean up this flow. Yeah. All right. Good stuff. Rocking and rolling. Not too bad. Trying to make this not as boring as possible, but I'm sure it is. Hopefully I'm not putting anyone to sleep. Right. 5. The graph of y equals 3x to the 4th minus 16x cubed plus 24x squared plus 48 is concave down 4, right? So you see concave down and you think, oh, that's when f double prime is negative. So you have to get f double prime, or in this case, y double prime, right? Duh, y double prime, and see where it's negative. All right, let's get y prime first. So y prime, integral of some of the integrals. I keep saying that. I should go back and redo this video, but I'm not because I'm already like 10 minutes in. So the derivative of a sum of the derivatives, difference derivatives, that's what we're using here. So here we go. So you're going to get 12x cubed minus 48x squared plus 48x to the 1 plus 0, right? Derivative constant is 0. Y double prime would be 36x squared minus 96x plus 48. And so now you have to set that equal to 0, and you're figuring out what can I actually factor out of this. It'd be great if you could pull out a 36, but it doesn't look like that's going to happen. Can you pull out a 12? That's a possibility. 12 goes into 96. I should probably have a calculator here to figure that out. All right. So let's just rock and roll. So you know what? Let me pull out. I can pull out a 6. That I can do, right? So if I pull out actually, let's just do this. I'm going to do what you guys would do, which is do a little of this and that works out. Yeah. Okay. All right. So let's pull out a 12. So if we pull out a 12, we're going to get 3x squared minus 8x, right? 8 times 12 is 80 and 16, 96, and then plus 4. All right. So then set that bad boy equal to 0. So I'll just do that right now. So if I set this equal to 0, now we want to factor this. You're not going to get anything that needs to be done with the quadratic formula on this test. So it's almost always going to be factorable. So what's going to work here, I'm going to go with the guess and check method. So 3x and x obviously gives you 3x squared. If I go, let's see, negative 4 and 1, that'd be negative 12. 2 and 2. Looks like that's going to work. All right, so let's try minus 2, minus 2. All right, so the outer product is negative 6x. The inner product's negative 2x. That adds a negative 8x. That's now I know how I did it. Didn't really do that very fast. It's a little embarrassing, but hey, what are you going to do? This is on the spot live. All right, so set each factor equal to 0. You get x equals 2/3, and you get x equals 2. Alrighty, let's see if we can extend this. We can. All right, so what do you got to do now? That's when the second derivative is equal to 0. So we want to make a sine line, and we'll chuck 2/3 here, and then 2, which is 6/3, would be here, and then you test. So maybe over here I test x equals 0, right? So if I test x equals 0, I like to test in the factored version. This is negative, this is negative, negative times negative is positive. All right, multiplicity is odd, so it should be flipping to negative and then positive because the multiplicity is odd on both of these factors, or there is no multiplicity, however you want to think about it. But if you did want to test, what are you going to test between 2/3 and 6/3? You can test something like 4/3, right? So 4/3 minus 6/3, that would be negative. 3 times 4/3 is 3 minus 2, that would be positive. Positive times negative is negative, right? And here you can test 500. Both of those are positive. So here you go. So you're looking to see where y double prime was negative, right? So then you can say that y is going to be concave down on the interval negative 2/3 to 2, or if they're using some sort of inequality, which they are, it looks like it's going to be 2/3 less than x less than 2, right? So we can write this as 2/3 less than x less than 2. Remember, with concavity, always want to use open intervals. Okay, open intervals when we're using concavity, and that is choice E. Whew, all right, let's rock and roll. Let's go to the next one. All right, so we are now on question 6. All right, so this one looks like a bread and butter. Questions get more challenging as you go if you haven't figured that out. We're still in the easy range. So we have the 1/2 integral raised to the, looks like t over 2 dt. All right. So how are you going to do this? We haven't really talked about linear u subs too much in class. We have a little bit. So I'm going to treat this, just do it as a normal u sub. So when you're integrating an exponential, it's usually a good idea to let your u equal the exponent. There's more than one option there, but we'll go with that for now. I'll write that as a half t instead of t over 2. Immediately compute du. The derivative of that would be 1/2. So du would be 1/2 dt. And now you just basically say, hey, I don't see a half dt, right? I see dt. So this is what we say, well, this is an equation. Just multiply both sides by 2, and you get this. And now you can replace this dt with 2 du. And this is simply e to the u. So I'd have the integral of e to the u and then 2 du. And then don't forget, there's this half out in front. All right, that half, I guess, is there just to distract you or confuse you. So now the 2 can get pulled out. When you pull out a 2 times a half, that's just 1. So you end up getting just this. What is the integral of e to the u? Easiest one in America. It is just e to the u. And since we have no limits, it's an indefinite integral, we do plus c. All right. And if you want to get it back in terms of x, if only you knew what u was, you do. It's equal to that. So you're going to get e to the 1/2 t plus c. So you found a family of functions differing by a constant such that if you took the derivative of it, right, you would get something equivalent to this expression. All right. So what choice is that? That looks like that is choice C. Choice C. Choice C. Smiley face. All right. Good. Let's rock and roll. Let's go to question 7. Question 7 got a little command notation for you. d dx of cosine squared of x cubed. Right. So you're being asked to take the derivative of something that looks like this. Got that shortcut trig notation, right? So this is when I would ask you, hey, what have I advised you to do whenever you see this shortcut notation? Take 15 seconds. Talk to your partner. All right, I walk around, and I'd say 50% of you probably got it. And the answer is rewrite it, okay? So rewrite this as quantity squared. So you have the cosine of x cubed quantity squared. That's what this means. And the reason why we do that is because it's easier to see the composition, which means it's easier to take the derivative using the chain rule. So you first want to view this as stuff squared, and the derivative of stuff squared is just going to be 2 times stuff, don't mutilate stuff, to the 1, subtract 1 from that exponent, times the derivative of stuff. So now what is stuff? Stuff is what I underlined in purple. That is still a composition. So how do you view that? You view that as cosine of more stuff. So what is the derivative of cosine of more stuff? It is going to be negative sine of more stuff, don't mutilate more stuff, times the derivative of more stuff. And the derivative of x cubed is just 3x squared, right? So then that's basically what you get. So it's one big chain of multiplication here. So you can multiply in any order you want. So I would multiply the 2, the negative, and the 3. If you heard that, that was my dog. Negative 6x squared cosine x cubed sine x cubed, and then you just see if you can find the choice. So we're doing question 7 here, so it looks like D is the one that's equivalent to what I have. All right, so choice D. All right, rocking and rolling. All right, 8. A little import there, a little preparation, a little ahead of time, cut and paste right there. All right, so let me just scroll some stuff up. I have like 6 computers open right now. Actually, I only have 2. All right, so here we go. So that's the picture you got. And it says, what value of t does the bug change direction? So you're like, all right, what graph am I looking at? You are looking at velocity. So change is a direction. So you're like, all right, what's the story with direction? So remember, when velocity is positive, the particle, the bug, the man on the unicycle, whoever is moving to the right in a horizontal motion problem. And when it's negative, we're moving to the left. Well, this is velocity. So you basically have a sign line. It's more like a 2-dimensional sign line for velocity. So all here, your velocity is positive, right? So these are all positive velocity values, right? And then the velocity is 0 there, and then the velocity goes negative. So where does it change direction? When the velocity goes from positive to negative. So t equals 6 because v of t changes from positive to negative. I didn't feel like writing all that out, but you get the idea. All right, so that's going to be question C. Okay, on question choice C. All right, so now we're on 9. So what's the story with 9? 9 says, what is the total distance the bug traveled from 0 to 8? So again, you see total distance, and you should think automatic in your brain, oh, total distance, you told us to remember, that's the integral, in this case, from 0 to 8 of absolute value of v of t dt, right? That's total distance. All right, so let me erase this. So that's a nice little eraser there, perfect size, okay? And you're like, all right, so I got to integrate absolute value of v of t. Well, I don't have absolute value of v of t, I have v of t. So how would I get the graph of absolute value of v of t? Well, it's easy. Just take the absolute value of this graph. So wherever it's positive, it remains positive, and wherever it's negative, it flips to positive. So this blue graph would represent the speed graph or the absolute value of v of t. So now to do the integral graphically, it's just net signed area, or in this case, it's just going to be area because we're always above the x-axis because it's the graph of an absolute value, right, of a function. Okay, so how do I do that? Well, it's just area. All right, so you can chunk this up into a triangle, a rectangle, a triangle, and a triangle. You can do the whole thing as a trapezoid here, however you want to do it. I'm going to chunk it up. Even though it's not the most efficient, just because, it's a little bit consistent with like the RAM problems we do, when the bases are actually vertical, not sideways. All right, so here we go. So this is a triangle. So what's the area of that? It's going to be 1/2 base of 2, height of 3. So that's just going to be 3 plus the area, oh, that's not very straight, of this region here. Well, that's a rectangle. So that's just going to be base of 2 times the height of 3 plus this triangle, which is basically this guy, right? It's the same thing, but I'll write it out. 1/2 base of 2, height of 3 plus this triangle, which would be base of 2, height of 1, right? I did it as one triangle. I didn't break that one up. So 1/2 base of 2, height of 1, and then you just rock and roll here. So this is 3. This guy is 6. This guy is 3. This guy is 1. So it looks like you get 9, 10, 13. So that should be choice B for 9, and it looks like it is, and we're happy. Okay? So again, pretty simple problem. Very easily you can make that more complicated than it needs to be. So don't, if that makes any sense. All right, question 9. We're almost there. All right, so what's the deal here? Actually, we did 9. 10. So it says, all righty, for question 10, we have the equation of a line tangent to the graph of. So y equals cosine of 2x, and you want the equation of tan at x equals pi over 4. So again, there's always this keywords in all these problems that should make you think of things that you've learned. So you see equation of a tangent line. What do you think? Very good, Duff. Y minus y1 equals m times x minus x1. Right, point slope formula. What do you need to have in order to use the point slope formula? You need a point and a slope. So let's rock and roll. So let's get the point. All right, so the point, the x value is pi over 4. How do you get the y value? All right, I hate this thick line. All right, so you basically chuck it in. So you do y of pi over 4, right? So you're going to get cosine of 2 times pi over 4, which is going to be cosine of 2 pi over 4, which is pi over 2, which is north pole on the unit circle, pi over 2 right here, and that point is 0, 1, and we're thinking x value, right? So that's just going to be 0. So that's pretty easy. All right. So you're like, all right, what else do I need to get? You need to get the slope. So in order to get the slope, you need to take the derivative, right? So here we go. So the derivative, y prime. Got to view this as a composition because it is. So it's cosine of stuff. So the derivative of cosine of stuff is negative sine of stuff times the derivative of stuff. So now what is that? Is that the slope? Liam? No, very good, Liam. It is the slope producing machine. right? It's a formula for all the slopes. We're not interested in that. We want the slope specifically at pi over 4. Notice the notational change here. So it'd be negative 2 sine of 2 times pi over 4, which is going to be negative 2 sine of pi over 2, which North Pole y value now is negative 2. All right, so we're rocking and rolling. So now we have our point, we have our slope. Let's just dump that into the point slope formula, and we're going to get y minus 0 equals, that's a 0, it's going to run to 0, negative 2 times x minus pi over 4. And so that's just going to be y equals negative 2 times x minus pi over 4. And we're hoping that's a choice, and it actually is. All right, so that's choice E. And we're good to go. All right, almost there for that first assignment. All righty, so here we go. Let's go to 11. So 11. All right, so what's the deal here? It says the graph of the derivative of f is shown. So this is f prime of x. Which of the following could be the graph of f? So when I like to do this, right, the first thing I'm going to do is see where f prime of x is equal to 0, right? So since this is f prime of x, it's 0 here and here. So that tells you there should be horizontal tangent lines on the graph of f at negative 2 and 2, right? So that's ruling this out. There's no horizontal tangent lines there. So see you later. See you later. So horizontal tangent line, this is close, right? This looks like somewhere between 0 and 2. So like at 1 and negative 1. So later. So you have a horizontal tangent line here and here. So that looks good. And you got here and here. So think about what we just did here. I mean, if you know that there are horizontal and tangent lines in the graph of f when the derivative is 0, then you've just made this a 50-50 shot, right? You guess between these two. So I have to think that most of you have that ability. So just think, you're given a graph of f prime, where is it 0? And then look for horizontal tangent lines on the graph of f. So now, well, what do I do now? Well, guys, this is a two-dimensional sine line, right? So this is the derivative. So it's negative when it's below the x-axis, and it's positive, when I say it, the y value is the derivative, when it's above the x-axis. So that means to the left of 2, your graph should be decreasing. Well, which one is that? It looks like that's E, right? See how we're decreasing here, and to the right of 2, that was left of negative 2. To the right of 2, right, the graph is decreasing in line with the sign of the derivative. And between negative 2 and 2, the graph is increasing, which makes sense because the derivative is positive. So this is going to be choice E. All right, so you're hoping to get a question like this. Don't overthink it. Start with that and then start with the basics, right? F increasing when f prime positive, f decreasing when f prime negative. That basic little idea there is going to get you that question correct. All right. All right. Question 12, promised land. Hopefully this wasn't too long. All right. So question 12, what we got going on? We got answers B. All right. Let's get to more than that. All right. So it says, at what point on the graph of y equals 1/2 x squared is the tangent line? So we want to know when the tangent line is parallel to 2x minus 4y equals 3. So solid little question. So you got to decompose this a little bit. So here you think, all right, tangent line is parallel. So this means equal slopes, right? So you're like, all right, slopes. So maybe it would make sense to first get the derivative, right? So if I get the derivative of this, y prime, it would be 2 times 1/2. That's 1, x to the 1. So the derivative is just x. So that's the slope producing formula for this parabola. Now I want to know when it's parallel to this. So that means when the slope of the tangent line is equal to the slope of this line. This is just a line here. So there's a couple ways. That looks like 2x minus 4x. That's horrible. 4y. All right, there's a couple ways you could do this. One is you could take the derivative of this implicitly and get what its slope is and then set them equal, right? So that's one way to do it. The other way is like, listen, this is a line, man, right? So, why don't I do this? Why don't I subtract the 3 over, add the 4y over, then divide by 4, everyone by 4. And now I have it in mx plus b form, so now I can see that the slope of this line, all right, is just going to be 2/4, which is 1/2. It's the easiest way to do it, and it's using, slope intercept and not derivatives. Although you could take the derivative implicitly and get the same thing, that the slope is a half. It's always a half because remember, it's a line. So basically, you take the parabola slope formula, which is x, and you set it equal to the slope of that line because equal slopes mean lines are parallel. Now, there's not much to solve there. Like if this would have been 3x plus 5 equals whatever, and you set it equal to a half, you'd have an equation to solve. But here, you don't have an equation to solve. All right. So you know the x value is a half. So unfortunately, though, if you look at all the choices, there are 5, and A and B have x values of a half. So in this particular problem, they also wanted you to find the y value. So the point on this graph, right? So you're like, how do I do that? Just plug the x value in. So do y of a half. So that would be 1/2 times 1/2 squared. 1/2 squared is a fourth. Ooh, right? Times a half, that's an eighth. To get y of a half equals an eighth. And so you're going to get 1/2 comma 1/8. And that would be the point. So if I did like a kind of a, actually, you know what? Let's try this, people. Let's try and see if we can get Desmos into play here. I don't know if this is going to work, but we're going for it. All right. So if I go to Desmos, open this bad boy up. All right. So let's graph y equals 1/2 x squared, right? Because that was the first guy. And then let's graph the other line, or the other line, I should say, which is 2x minus 4, 4y, 4y, pull equals 3. All right, so that's what we got going on. And we wanted to figure out when the tangent line on the parabola was parallel to the tangent line on the line. So we got that was the point 1/2 comma 1/8. So that certainly seems reasonable. Let's actually write in the equation at line just to kind of see if it is kosher. So we should be able to do that. So it would be point slope formula, right? Y minus an eighth. And the question didn't ask this. I'm just doing this to show you for kicks and giggles. The slope was x, right? And it was a half. So 1/2. And then x minus a half. And look at that. Howdy doody time. So you just found the point, right? Wuja. All right, there, that's a half comma an eighth, right? You just found the point on this graph where the tangent line was parallel to that. So that's pretty sick. Hopefully you can see that. All right, that's that. That's a pretty comprehensive answer key. So hopefully it makes sense. If you have any questions, just hit rewind. All right. See ya.